What's up, guys? Welcome back to the podcast. So we got Patrick Butler, who goes by Professor Butler on TikTok. He's got a lot of good videos and his account is blowing up in numbers. So go check him out. So what we're going to talk about here with Patrick is building automation and how an HVAC tech that doesn't really have a ton of building automation experience, we're going to go through some things so you can better understand it. And I'm going to tell a story how a building automation guy and myself got into a bit of an argument because he thought his trade was above mine. We need to work together equally to get through and solve problems. So no trade is bigger than the other. We all have our own part. So let's get to part one with Patrick Butler. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, so Patrick, let's get into the conversation. You're a commercial tech, so am I.
Yes.
You have experience with building automation. I've got a little bit, enough to hold a conversation with you. Like, I know about it. I've done some install, some troubleshooting. I've done some coding, very, very minimal at that, to be honest with you. I did like a full week course. How 16 years ago on reliable controls out of Vancouver, BC. I did a course on that a while back and got into that a little bit. But let's have a conversation that weaves in commercial HVAC, weaves in controls, because controls is a big part of commercial HVAC these days.
Sure.
And let's weave in teaching methods of today versus yesterday, right? So
Sure.
building automation at this point in time, capabilities, like we can do pretty much anything, right?
Yeah. Well, so usually from what my experience is that people that get pushed towards the building automation section of our trade tend to have, computer skills and usually have an electrical background. So it could be as far as, they started off as an electrician's apprentice or electrical, or they were in the fire alarm, access control, things like that, where they're already working with low voltage and they end up going into either through people they meet in the field or just a complete change. But that's at least the experience that I've had. People always said, oh yeah, I got my start in, data, Ethernet, and they kind of work their way towards commercial controls. I do feel it is a very advanced part of our trade. When people hear controls, they tend to think, low pressure control, high pressure control, basic unitary controls, opposed to, a control system.
Fully
That
automated control system for a building. Yeah.
Sure, for energy saving, right? You want to save, the customer wants to save money and they want to be able to monitor their equipment and systems, and especially trouble. If you have a data center or a hospital, you need to know if a chiller went down or if, the boiler plant is not operating. So in order to do that, obviously there's ways of wiring and implementing things to make that happen for the customer.
Yeah. Let's talk about, maybe we can give, so there's people in the audience that have not seen building automation. They've never touched it. So maybe after, I'm going to tell you a little funny story about a control guy and me being a tech on site, and the argument we got into was pretty funny. But maybe after I'm done that, we're going into cooling season. So maybe we can take like a small chiller plant, a chiller, a couple of pumps, and some controls, and talk about how we tie the controls in to run the chillers, pumps, etc. Just for the audience's sake, if you want to do that, right? If you don't mind.
Sure.
Cool. So I find the best controls technicians know the trade of HVAC from a mechanical standpoint really, really well. They're usually the best when they get into controls and learn it, because they understand the mechanical side. Then when they understand the controls, they know both. So I was dealing with this heat pump, and I probably told this story before, but this heat pump was in a ceiling. I was told there to go make a repair for it. And after I was done making the repair, I wanted to be tested from the building automation side. So I tested it myself, right? I had jumped it out cooling, jumped out heating, fan, all that stuff worked properly.
Sure.
Okay. And
Locally, you did that.
Locally, I tested all that. But I'm like, you know what? We should get the controls guy to test it. So I called him up. He says, yeah, I'll test it tomorrow, because he couldn't test it off site for some reason that day. Anyway, so he comes to the site the next day, and he's like, he calls me and he says, hey, when I run it in cooling, it's actually heating. When I run it in heating, it's actually cooling. I said, well, that sounds to me like it's just a programming change that you can make, and it should be fairly easy because that heat pump works fine. And then he started to argue with me that I messed up my work and he's made lots of money off of mechanical guys and stuff like that. And this guy was like, he had his back up against the wall, like a chip on his shoulder. And I didn't know what his problem was, but he
Sounds like
didn't,
ego. Ego gets in the way of
well,
people.
he did not understand the mechanical side of the trade
Sure.
whatsoever. So as I'm explaining it to him, you could kind of sound like he was a little timid to speak, and then all he could come out with was anger. It was the only emotion he had. And I said, "Just do me a favor." I said, "Just do a control change, a little code change, or swap around some outputs from your controller to that machine, and just reverse it, and it'll be fine because I've tested it locally and it's good." So I never heard from him again, but anyway, the argument was funny. So let's say we got like a little small chiller. Let's
Mhm.
say we've got a couple of pumps and we want to control them. Let's say we want to control the chiller based on loop temperature,
Yep. Chilled
and we
water
want
set
to,
point.
yeah, we want to control the pumps based on like a lead lag situation where you only need one. So it's basically duty standby. We have one running and one on
Mhm.
standby, and then they
Yep.
switch over like every week or so to keep equal runtime. So maybe take
Sure.
us through a small system like that.
Sure. So if let's say here we're going to need some data points, right? We need to know that you can have the chiller as a mechanical piece of equipment, then you have your pumps, and then you need some type of controls, either external to the chiller and the drives for the pumps or starter. You'll need some type of, DDC. Okay. The chiller, now you can either control it two ways. You can do it with like an analog signal of
You
DC
said
voltage.
you said DDC, so
Yep.
people are going, "What the heck is he talking about?"
Sure. Direct digital controls. It's
Yep.
another word for, a controller
Hmm.
in general. People will say DDC,
Yeah.
they may, there's a few different words, but yes, DDC is an acronym for direct digital controls.
Okay. Perfect.
Yep. So you need some type of brains to interact the two, to do the handshake, right? Because you have two pieces of equipment that are separate. Your chiller, we're going to monitor for alarms to make sure it's operating properly. And we're going to be feeding it a set point, right? We want to know what temperature does the building need for a demand. If it's a day like today here in New York, the sun came out, it got to like like low 50s. You don't need to run 40-degree water. You may just do, 48 or 50-degree water to satisfy the load. So the chiller, again, is going to be told to come on by the BMS or by an outdoor air temperature sensor saying, hey, it's cold enough. Let's operate.
Let me stop you there because I want to paint a visual
Mhm.
for the audience here. So in the room, we got a chiller, and so far, uh, we're controlling that chiller based on a chilled water set point. And so basically, we could have like an electrical box in a mechanical room. There'd be a controller in that electrical
Mhm.
box. That
Yep.
controller would be powered with 24 volts. The most minimum simplistic way to do this, we run a sensor from that controller out to the chiller supply line or
Yep.
chiller return line. We could do both
Or both.
or
Yep.
both, right? And
Yep.
then,
A flow sensor, right? To make
yeah,
sure that we have actual water moving.
flow sensor. Yeah, we could also have like an operator, like it's tied into fire alarms or something like that. So if the fire alarm goes off, it cuts power to everything. That happens once in a while with equipment. But we could have all these kinds of things, but it starts with that controller based in that box. We send our sensors out to
Mm.
whatever we want to sense. Those sensors will give the controller feedback,
Feedback. Yep.
and it will decide what to do based on the program you've written it. And then if it says, "Hey, chiller, come on," we're going to send outputs from the controller to the chiller. So we got inputs coming in from sensors and outputs going out to devices like chillers, pumps, etc. Right? Um, am
And
I
you
right
could
on that?
have so back to the controller real quick. You could have two different types of controllers. You have a programmable controller where all the logic is written by a programmer or
Mm-hmm.
controls technician, or
Yep.
you can have what's called an application specific controller, which it's designed to run a chiller. Not part of the chiller, but it's a module that has everything in it to run the chiller. And then
Mm-hmm.
you kind of plug and play with the sensors it needs and the inputs and outputs that are needed.
Yeah. Yeah, it makes sense. Just like a boiler, you could get a boiler control, and it's already set up for a boiler. You just got to make some dip switch settings or whatever, right? Just,
Yeah, like
but
a reset
it's
controller or something
yeah,
like that. Yep, absolutely.
yeah,
Same
but
type of
it's
difference. That would be an application specific because it's made for a specific application.
correct, correct. So the chiller, we got the inputs, we got the outputs to the chiller. If we want to run the pumps, we can send outputs from the controller again to, like you said, a VFD
Yeah,
or some sort of
potentially, or a starter.
or a starter, and we would obviously have a written piece of code for that. Or if it was application specific, maybe it's just a couple dip switches or a couple of inputs inside of it to turn them on. But essentially, it's very simple. It's like having, imagine a circuit board and a furnace. It's very similar to that almost, right? Because a circuit board and a furnace takes inputs in, and it has outputs that go out to like induced fan motors, indoor fan motors, stuff like that. But the inputs that come in are from like safeties and stuff like that, limit switches
Yes,
and all that.
basically all circuit boards that are involved in what we do is just inputs and outputs, right? You have in the board, you have what's called like a chip itself is a microcontroller.
It's like
It,
logic, yeah.
it's the logic, okay? So you're getting input and output, right? Input in, output out. So whatever you're doing with those, again, is based on whatever your needs are. And that's how every circuit board in our systems work. And I studied electronics because when I got in the trade, I would walk up, I'm sure to you as well. You would ask a journeyman or lead technician, be like, hey, what's that board? Oh, that's just the furnace board. Well, how does it work? It just does whatever it does. It's ones and zeros. They didn't really understand how the board
Hmm.
worked. Well, I'm like, I want to know how it works. And so I started studying electronics to help understand. And that's how I found it's like they're all basically the same if you break it down to its core.
Yeah, for sure. So one of the points that we should touch on is when we're expanding out to multiple controllers controlling multiple pieces of equipment. They
Uh-huh.
all have to be like, I've sat in the basement of a high rise. You turn on the computer and you can see like everything in the building. You can see the set points, the room temps, the supply
Mhm.
airs, and just for everything. And it's crazy when it's all working right. It's really cool to just sit there and you can actually go through and find issues that someone might not know exist yet, but you could
Sure.
find them through different alarms and set points or
And
feedback you're
and we
getting
also
from them.
do preventative maintenance on BMS, on building automation systems or building
Yes, we
management,
yes, we do.
where just like an equipment PM where you go in and you're checking changing filters, belts, trying to prevent issues, we do, building automation PMs where we go in and look at the system to see if we can see something that may be trending bad, right?
Mhm.
Because you can make trends of graphs of data.
Yep.
You can look at it and see, hey, wait a second. Why is the chilled water temperature rising all week? What's going on? And then that's how you can look mechanically, or that's really where its strong suit is not just operational, but is saying, hey, you know what? Maybe we need to go clean the strainers, or maybe we need to, do some type of maintenance on the water side.
Yep. 100%. And what I'd like to talk about is the fact that we have to connect these pieces of equipment with their controllers through a network,
Mm,
right? And we
Yep.
have to wire that network almost like daisy chaining these controllers. And I didn't know this. Like when I started to do a bunch of Mitsubishi stuff, we had to network them together, like
Like the
wire them
Mnet.
together. Yeah. And I mean, I didn't understand what shielded cable was back then. I had no, I'm like, oh, it's just got foil insulation on it. Cool. I didn't know
Yeah, guys,
what it was
they just
for.
cut that off. They cut it off.
I didn't know what it was for. And sometimes, yeah, you would, that ground cable that's touching that aluminum shielding, I would sometimes cut it off until I understood what it was for.
Sure.
Uh, so let's talk about shielded cable for a minute that ties in these networks or creates the network.
I have a good story about it.
Okay.
I got All right. So, shielded cable, when you're dealing with any type of controls that are on that, that are communicating, and that goes for, like you said, VRF systems or, mini split systems that are communicating, or even, a home split system that's communicating. The voltage that's on those wires, we call that a communication bus. Okay. The two wires, the DC voltage is very low. Okay. So it could be up to like between 0 volts and 2.5 volts DC. So that's not a lot in the grand scheme of voltage. So now imagine that cable is laying on a fluorescent light or near an electric room that has a bunch of transformers that are creating electromagnetic fields. Well, what do you have when you have a electromagnetic field near a copper conductor, right? You induce voltage, right? Voltage can be induced onto that cable.
Yeah.
So the shielding is acting as like a Faraday cage, which is preventing any type of penetration from electromagnetic forces around the cable or wherever the cable may run through. So the first time I did a job that it really mattered on what's called there's different protocols that things communicate at on building automation,
Hmm.
and it's basically a set of rules that that voltage follows to transmit that data. There's BACnet, Modbus, LANWorks. There's a few different types, and they all have their own set of rules. So I was familiar with LAN, where you didn't use shielded cable. It didn't require it for its protocol. So
Hmm.
when we did our first BACnet job, I ran the daisy chain comlink the same way I did. Well, the engineer, application engineer for controls, ordered all this shielded cable. And I was like, all right, I just wired it as I would, white on positive, black on negative, and the shielding and the ground I just cut off. Well, now I ran this across this whole factory, across the whole ceiling, across the whole factory. And when I went to commission it and turn it all on, we had data dropping out left and right. Nothing was working, and we couldn't figure out what it was. And it turned out what we created was a giant antenna. All that wiring run throughout the whole building was just picking up EMF from all over the building. It was getting into the cable, acting like a antenna, and was destroying our signal. We had no communication.
Hmm.
So we had to go back, trim the cable back, and then take all of the grounds, wire them together, splice them together, and then drain it. Now, what draining is you ground it and bond it to the controller. Usually at the beginning of the link where the main controller is, you ground it and at one side. The other ones are just spliced together and taped back all the way through from your first device all the way to the end.
Yeah.
If you connect them at both sides, you can get something called an earth ground loop. And the voltage kind of can get confused on where to go, and it can kind of just like circle
Hmm.
and then not drain to ground like we want.
Yeah. So I didn't do that, but on one of the first Mitsubishi jobs I did, or maybe the second or third or something like that, because I think in the first couple I was just cutting that ground cable off. Then we started to, when we daisy chained our network in, I was grounding that cable at every single point. We never had problems with it, but I didn't find out until I went on the reliable controls course that, yes, like you said, you ground that at one spot and one spot only to drain any interference that that cable might be seeing from outside sources, like exactly how you explained.
And it can be anywhere along the link, but we tend to do it at the main panel because that's where everything's starting. And if a technician goes to a building for the first time and they open that panel, they're going to see that it's okay. The shieldings are done. We're drained. So
Yeah,
that's why we do it there.
for sure. Cool. So, I mean, that's kind of like a quick introduction to building automation. You could go way more in depth. I'm surprised there's not like maybe there is a building automation podcast that just talks about building automation, because you could talk about that for a
Yeah,
while
there
because
is
it's
one guy on YouTube. I forget his name, but he does have a building automation YouTube, and he does like solo podcasts, which are videos
oh, okay,
explaining things. I can get you his info, but he's really good.
cool.
It's just a very broad topic, and a lot of people say, "Oh, I want to do controls, or I want to do BMS work," but where to start, right? And like you said, Garrett, start in the beginning. Be a technician. A technician, when you understand how systems operate and you understand sequence of operations and how these systems work, integrating them into a building automation system and then commissioning it, it makes it so much easier because now you know what's supposed to happen and when.
Yeah, no, you're 100% right. So I last part, I'll just say this before we move on because I want to get your take on education past and present as we discussed in the beginning. I
Mm,
find it's not funny, it's just interesting because a lot of the stuff that we just talked about, it's moving its
mhm.
way into a lot of the residential stuff. Like
Sure.
capacitors and contactors are becoming a thing of the past in an outdoor unit, heat pump, air,
Mhm.
AC, whatever it is. They're getting smarter. They're coming with um, application type controllers, inverter technology.
Inverters.
And the residential guys, they're freaking out. But what some of them don't know is this stuff has been, and I just said it to someone on a podcast or two ago, it's been in commercial for decades.
Sure.
It's just moving into residential now, and it's worked fine there. You know what I mean? It's been proven to work, and a lot of these resi guys are freaking out. So if you have some advice for a residential tech that's never seen something like this, is used to contactors and capacitors, what's the best way to make that transition to understanding more of this stuff?
So a lot of the videos that I make, I look at things like that, right? Where what are topics that are becoming in different parts of the trades, and seeing more guys that are in like the warmer climates of Florida, Alabama, here in the States. They're seeing inverters and they're like, oh, I don't want nothing to do with that. What I did, again, I'm going to speak for myself personally, and what worked for me is I started to learn electronics.
Okay.
There are these little boards that are called Arduinos, and they're very small, they're very inexpensive, and it's a microcontroller, just like what are inside circuit boards, and it comes with a kit, like those electronics kits we had as kids with light bulbs and stuff like that, but this is on the microcontroller level. And they sell these little kits that have sensors, LEDs, little motors, things that you can take and write the code, wire it, and watch it work. And that's how I started to learn. And there's so many videos on YouTube and all over the internet on how to do this. It's very simple. And that really gave me an understanding on what's happening in these controllers. And that literally it's just voltage, and it's controlling voltage on, the voltage levels, how much, the quantities. And it's not as bad as you think. And I know it's intimidating. You see all these circuit boards, like, whoa. A lot of it, when you look down, is power boards, right? You're filtering the power because these controllers want clean power. So you have these big capacitors and big, inductors, and you're like, what, whoa. Mostly it's just cleaning your power up, right? Making sure it's nice and clean. And then you're controlling it, how you're, without getting too technical, the frequency, right? The change of positive to negative. Like here in the States, and kind of 60 hertz per second, right? You're 60 cycles a second. Inverters just control that, of how slow you do. And when a motor gets that, it can go slower or faster. And the circuits that do it are pretty simple, and they're just packing it into one board.
Yeah.
So I think learning electronics and watching some videos on the internet will really help you understand that they're not that difficult and not that advanced as you might think. They're just intimidating.
Yeah. I agree, but you got to get your feet wet in order to understand. You got to
ask
read,
questions.
you got to watch, ask questions. Just do what you can to gain as much knowledge as possible.